This filthy old thing is a Lucas 2M100 starter motor. It was working fine, but there is a small spring that is shredded to bits, and I'll replace the brushes and give it a quick tidy while we're here. Nothing major. A smart man would have paid more attention to how the brushes are arranged, but I just yanked them out. The first small hurdle is replacing the oil light bushings. The small end is a bushing in a blind hole. You've probably all seen this trick before. I've machined a piece of round to nicely fit inside the bearing. This works better with grease, but forcing grease into an oil light bushing would wreck it, and I might want to reuse this bearing, so I'm sticking with oil. The theory here is to use the number 1 tool to smash the oil and drive the bearing back out the way it went in. I don't want to crack the case by hitting it too hard, so I'll just try pressing with the vise. Yeah, that's obviously not going to work. More hammer. Oh, look, here it comes. Now, as far as pulling the rest of the cap apart, nah, it's riveted in place. Let's just flush it out first, see what comes out. Now, the broken spring. This little spring needs replacing. It stops the gear bouncing into the flywheel while you're rolling along. Unfortunately, to get at the small spring, we need to remove the big gnarly one. Which is fine for me, because I just restored a spring compressor with exactly this task in mind. You are fucked. That's a lot of potential energy built up in that spring. You ain't getting this guy off with just a hammer and pliers. Once the demon little clip is released, the spring and everything else on the shaft just slides off. The end of the commutator is actually pretty worn down. It's hard to show, but there's probably about a 1mm dish in the face. What next? Let's make the screws nice and shiny. And FYI for those who watched my DIY plating video the other week, this is the zinc plating setup that I normally use. The zinc bath is zinc chloride based. It's a purchased mix, not home brew. Obviously I'm not going to reuse these smashed up washers and springs. It amazes me that these parts are all still available, and mostly cheap too. I think the sundry parts kit was about £2. I couldn't get the old brushes off this metal tab with my soldering iron. I think the copper strands may have actually been spot welded into the tab. Anyway, it doesn't matter, I'll just solder the new brushes into the copper from the old wire. Now, the new oil light bushings. Oil light is amazing. It's a fused bronze material full of holes, a bit like a sponge. Watch the side of the bearing. See the oil squeezing through? I'll try and do it again with the big bearing. The small bearing is probably good to go with the oil forced through it, but generally I soak these things for a day or two. The oil they soak up now is the oil they have for life. You might laugh at the amount of grease I'm using, but this is the only lube these parts will ever see. And besides, any excess will just fling all over the flywheel, preventing rust. Now, getting the little demon to clip back on. I could make another special tool, but I'm really not into doing that twice in one video. So I'm going to mash it back on with whatever I have lying around. And after 2 weeks of trying, I'll make a proper tool. You missed the moment. I really didn't expect this old bearing to be the golden ticket. But there we go. Excellent. I don't think the brush springs really need replacing, but the sundry parts kit came with 4 new ones, so I may as well. The new brushes are a little rough. They need to slide freely inside the brush holder. A couple of strokes against a smooth file sorts that out. Getting the cap on while holding the brushes in place is a little fiddly, so please excuse the footage of hands. I once worked with a guy who would tell women he was a hand model. True story. Now, because I'm a pedantic sort of character, I don't really want the starter to fill with grime and cow cack. So I decided to put thread sealant between the cap and the case. This won't fully harden, but will hopefully fill the voids and prevent ingress. And of course, I can't do the same between the case and the bracket, because that would stop the motor from earthing. Just kidding. You know I tried it anyway. So, she's all hooked up. Let's see what happens. Okay, so let me quickly get rid of that sealant. 5 minutes later, and we're back. I cleaned out the sealant from between the bracket and the housing, so we should be good to go now. Oh, wait. I haven't actually explained what's supposed to happen here. This gear engages with the flywheel and starts the engine. In most starter motors, there's a solenoid that pushes the gear into engagement with the flywheel. But this old style design relies on thrust and the weight of the gear. The flywheel sits about in line with where the flimsy little spring and spacer are. When the starter motor starts spinning, the big gear wants to lag behind, and so slides backwards down the spline. As it starts to do that, it will catch the flywheel and start the engine. And as soon as the engine starts running under its own power, it flings this gear out of the way. The gear is flung back along the spline, smashing into the big chunky spring. The big spring is only there to act as a shock absorber. Enough procrastination. Let's get this thing spinning. Woohoo! Ah, wait. Which way is that spinning? I must have put the brushes back in the wrong place. I moved the sparking up to the battery terminal, so as not to fry my nuts. Ignore that and watch the gear start to slide back. It's a little stiff sliding for now, but so long as it moves enough to catch the flywheel the first few times, it'll lap itself in, no problem.